Hi, my name is Oliver Taradash, and for this physics project, I'm going to demonstrate how the lens inside a smartphone camera works. I'll explain how the lens focuses light, how the camera adjusts when objects move, and I'll use the lens equation to calculate the focal length. The camera in a smartphone contains a tiny convex lens. When light from an object enters the lens, it bends and forms an image on the camera's sensor. For the image to be sharp, the light rays need to converge exactly on the sensor plane. Whenever the object distance changes, the lens has to readjust to stay focused. That's why you see your phone autofocus when you move it closer or farther away from something. And that's a demonstration that I'll be showing next. So now my camera is on the Sharpie. I'm going to move my camera closer to the object, and you'll see the image go blurry at first, and then I'll do the zoom in. So I'm going to move my camera closer. It's blurry, and then it'll focus. And I'm going back to what it originally was. It takes a second, and then I can focus again. I move the camera backwards. It takes a second, and then it has to focus. When I move the phone farther away, it has to refocus. That happens because the object distance keeps changing. And the camera automatically adjusts the lens so the image becomes sharp again. Now I'll switch to the zoom in. When I zoom in, the lens system increases the effective focal length. That makes the image appear larger on the sensor. Switching to the wide lens does the opposite. It increases the field of view and decreases magnification. Now let me show you. See, now I'm zooming in, back to normal. It takes a second, and then it focuses. And now I'm gonna switch it to horizontal. Zoom in, and zoom back out. Now let me explain the physics behind this refraction and the thin lens equation. We have 1 over f equals 1 over dO plus 1 over di. F equals the focal length of the lens, dO equals the object distance, and di equals the image distance. For a phone camera, di stays almost constant because the sensor is fixed in place. So the lens changes focal length slightly to keep the image sharp. Now the calculation. Now let's estimate the focal length of the phone lens using this equation. If the object is 10 centimeters away, then the DO, the object distance, will be 0.10 meters. The DI is 0.004 meters. And then 1 over F equals 1 over 0.10 plus 1 over 0.004. And then it goes 1 over F equals 10 plus 250 equals 260. So that means F equals 1 focal length equals 1 over 260, which is 0.0385 meters, which is 3.8 millimeters. That matches what you expect for a real smartphone camera lens. In this project, I demonstrated how a smartphone uses a convex lens to create sharp images. I showed how the camera adjusts focus when the object distance changes, and I calculated the focal length using the thin lens equation. This connects physics of lens directly to a device we use every day. Thanks for watching.